In this module, we're going to be looking at the physics of current, which is the movement of charge through a conductor. Let's take a closer look at what happens in a circuit. Charge is flowing along the wire. The rate of flow of this charge is called current. It's a number of coulombs that pass each second. 1 coulomb per second is known as an ampere, named after the French physicist André-Marie Ampère, who worked in the field of electromagnetism in the early 19th century. Sometimes you may see a reference to current density, which is just the amount of current that passes through a certain cross-sectional area of wire. Current density is important to measure because too much current going through a wire will lead to heating of the wires and perhaps fires. Let's think for a moment why a wire would heat up as a result of current flowing through it. Electrons move quickly under the influence of electric field force, but make many collisions with other atoms and electrons. The backwards force of these collisions can be thought of as a resistive force like drag. The kinetic energy they gain from the electric field is quickly transferred to the material as thermal energy, heating it up. The forward push of the electric field force is balanced by the backwards push of this drag force, resulting in a constant velocity. This average velocity of the free charges is called the drift velocity. Interestingly, the drift velocity for electrons in a wire is roughly 1/10 of a millimeter per second. So, if the electrons in a wire are moving that slowly, how does electricity move through a wire as fast as it does? Remember that a conducting wire is always full of electrons. As the new electrons move into one end of the wire, the electrical force between all the electrons forces an equal number out the other end. You can think of the analogy of a water hose that is already full of water. When the new water is forced into one end by a faucet, the water at the other end is almost instantaneously pushed out. Because it's difficult to increase the charge density of the wire, the signal caused by the electrons pushing on each other down the length of the wire travels at nearly the speed of light. Let's think for a moment about the power of an electric current. Remember that power is defined as the rate of energy transfer, or the amount of energy transferred per second. It turns out that for electricity, this is given by the current multiplied by the voltage. Why is this? Why is it that amps times volts gives you watts? Well, let's see. Remember that an amp is the number of coulombs passing by per second, and that a volt is the number of joules per coulomb. So together, they tell you the number of joules of energy that are transferred by a current each second. So with that, we come to our first circuit diagram. In order to simplify the drawing of complex electrical circuits, we use simplified diagrams. In this illustration, current flows out of the battery, through the light bulb, and back into the battery. This diagram shows exactly the same thing, with a battery and wires connecting it to the symbol up top, which is the electrical symbol for a resistor. A resistor is anything in a circuit that impedes current passing through. It could be a light bulb, a toaster, or anything like that. We'll be looking at resistance in the next module. Finally, we'll be working mostly in this course with the type of current we've been describing so far, called direct current. Direct current flows in one direction through a conductor under the influence of a constant potential difference. It has limitations though, especially when electricity is needed to be transferred over conductors over long distances. For many applications today, we use alternating current, where the potential difference varies. In fact, the potential difference reverses itself back and forth, and so there the current flows back and forth through the circuit. In the United States, alternating current, the type that you find in your household outlets, alternates direction 60 times every second, in other words, at a frequency of 60 Hertz.